But we'll kind of skim over the Unit 5 stuff since that's a little bit more recent in your memory, and we'll go back and hit some of that older stuff. Did it come through? Were you asked if you wanted to save it? Okay, good. All right, so you can save it, and we will move on to the next page. So just a little background info to hopefully ease your mind. I don't want to stress you out. But on the Part 1 test, there are going to be 12 questions, which will be 60 points, and it's computer scored, just like all Part 1 tests are. That reminds me, I need to take out, there's a few questions on there from Unit 6, which we did not do. Let me write myself a note, and I will take those questions off. So normally there would have been 15. And if you already took the, Part 1, I know there's a few of you out there that did, then I will adjust it. If it shows that you missed those and it's counting against you, I'll fix your grade. Let me know if it looks like that's not the case, but later this afternoon I'll go and right now it's probably showing 15 questions, but it'll go down to 12 because we didn't do Unit 6. And then on the Part 2, there are 4 questions, and you can pick 3 out of the 4. So you only have to complete 3. It's 45 points, teacher scored like all Part 2s are, so make sure you get that in the Dropbox. Oh, and this should say Tuesday. The May 17th is correct, but the Thursday part is not. So this year is weird. We end on a Tuesday. So 1 week and 1 day from now, you guys are going to be done. Okay. Yeah, I'll do that. I'll give you guys extra credit for that last one if you get it right. Okay. Now, if you're all through Unit 5, all done with Unit 5, and you look at your grade and you have an A, then you are excused from the Part 2. Okay? So some of you have already emailed me about that, and I've already verified, yes, you're excused from the Part 2. If you are not sure, send me a K-mail, okay? Because it would be better to be sure than for me to enter a 0 in there for you. That wouldn't be good. So just so you know, I will also, let me write myself a note, send K-mail about that. So I'll try to K-mail you proactively on that. But if you do finish up Unit 5, you have everything completed except for the final, and you have an A, you are excused from the Part 2. Okay? But if you end up having to take it, you pick 3 out of the 4 questions, and then on the Part 1, there's only 12 questions, okay? So just be sure to have all of that finished by Tuesday, May 17th at midnight, because everything closes down. So 1 week and 1 day from today is how much time you have, okay? All right, so here's something that you guys should all have. And you might have a different version of this, but these are all the formulas that we covered when we were talking about the 3D stuff. So long time ago, that's what I'm trying to refresh your memory. But don't forget how to calculate the volume and surface area of these different shapes here. So go back and dig up your formulas. Make sure you have those for you. So let's practice one. It says find the volume of the following triangular pyramid, rounding your answer to 2 decimal places. Anybody want to give this one a try? So this is a triangular pyramid. Anybody remember what you have to do? It looks like it's a good thing we're reviewing. I don't see anybody really wanting to jump on the whiteboard. Good, Mason. So yes, here's the formula. That's always a good place to start, right? It does ask us for volume, so make sure you're using the volume formula and not the surface area formula. It's the area of the base times the height divided by 3. So remember, the area of the base, the capital B, is where you want to start. So what's our base shape? If it's a triangular pyramid, it's a what? A blank. Yeah, it's a triangle. Okay, so we're looking at this triangle down here on the bottom, and we want to calculate the area of that triangle. So the area of our base, because it's a triangle, we want to use the area formula for a triangle, which is 1/2 base times height. Now be careful. Remember with these how it's easy to get the base because you have a capital B, you have a lowercase b, we have a height here and a height here, and so it gets quite confusing. So definitely think through this and be careful. This height is the height of the triangle that's the base. So the 17 is the height of the triangle that we're working on right now, okay? So we have 1/2, and then the b here is the base of that triangle. So this is our lowercase b. So we have 19 times 17, and then divided by 2. Okay, so 161.5, Mason says. Okay, so now that is our capital B, our area of our base. So that's what capital B represents in the formula. So I'm going to come back up here and plug that in. I have 161.5 for capital B. Now the height here, think about, okay, what are we calculating over here? And same thing down here. If you're confused, like, okay, there's an H here and there's an H here. Are they the same? Are they different? If you're in this formula, say, well, it's the height of what? What am I calculating? I'm calculating the area of the base, which is the triangle. So this is the height of the triangle. Here, we're calculating the volume of the pyramid. So this height needs to be the height of the pyramid. So what's the height of the pyramid? Yes, that's the 23 right here. So this is the H in the volume formula. Okay? And then divide that by 3. So what would you get for your final answer? So remember, especially if there's an odd number or a number that's doesn't go into that evenly, what I suggest to you guys with your calculator is type in the top 2 numbers, multiply the 161.5 times 23, then divide that answer by 3 so that you don't get too much rounding error. Rather than putting in, because you could think of this as 1/3 base times height, and then I know a lot of you have had the tendency to plug in like 0.33 for the 1/3, and I'd rather you don't. I'd rather, so that you don't get too much rounding error, I'd rather you keep it as a 3, multiply these together first, and then divide by 3. Okay? All right, good. So I'm seeing 1,238.17. What would your units be? If it's volume, we have centimeters something. Centimeters, what would be the exponent? Yep, volume's 3-dimensional, so our centimeters are cubed. All right, very good. All right, a little bit of a refresher. How do you guys feel about going over that one? Good. I see a thumbs up from Wada. Yes, I see a thumbs up from Emma. Amelia's like, well, it's better, but I still need to review. So I understand. Okay, here's another one. What's the volume of the sphere? Let me give you guys polling options. Okay, go for it. Anybody want to do it on the board for us? All right, Mason, go for it. You have whiteboard privilege already. Yes, it is a lot, Amelia. But you can reference your formula sheet. So that's why I say just have all these ready ahead of time. A lot of these formula sheets are available in doc sharing if you lost yours. So yep, definitely organized. That's why I say to go through and practice a few of those that are on that list of problems to practice, and that way you'll have all that stuff organized. I think you have it right, Mason. I was just writing it up here to remind everyone, but I think you have 4 times pi times r cubed and then divided by 3. Is that what you have there? You wrote it in a different order, but you have all the pieces there. Yes, it is, Anthony. You're right. And my suggestion here again would be, once you find the radius, to do the radius cubed first, because with PEMDAS we do exponents first, and then multiply that by pi, and it does say here that you want to go ahead and use 3.14 for pi. So you'd find your radius and cube it, multiply by 3.14 and then by 4, and keep all that in your calculator, then divide by 3. Okay, now these answers are pretty different, so it shouldn't affect you too much on rounding error. Even if you had rounded this a little bit early, you should still get close to the correct answer. But as a general rule, that's what I would suggest, is go ahead and multiply the top stuff together first and try to keep all that in your calculator. So just, the more rounding you do throughout the problem, the more likely you are to have your final answer thrown off a little bit. So it's always a good idea to keep everything in your calculator if you can. But yeah, it looks like a few of you have the answer already, and it's looking good. So just keep working, guys. If you're not done yet, keep going. Oh, okay, awesome. Derek's jumping on too. No problem. That's awesome. The more the better. This is so weird. I don't know what's up with my mic the past couple of weeks. Since I did that Illuminate update, those updates just are not good things, are they? I can't quite see what, or I don't know what you use. Let's see, what did you use for your radius, Mason? You didn't write that down, so let me just double check. Well, be careful. It says that 14 meters is the diameter. I think Derek wrote his up here to give you a hint. Yes, which is a common thing to do. So just slow down. This is a good reminder for everybody, right? Make sure that you don't forget to divide by a half, or to divide by 2. Oh, I know, sometimes it's easier to start over, but yeah, this would be the correct work, or what you'd want to start with. So thank you, Derek, for noticing that and reminding us that we want to use a 7 for our radius, because the 14 is the diameter, which is twice as much as the radius. Well, let me go ahead and I'll write out what I have here. That way we can move on. So we have 4 times 3.14 times 343 is what I got from 7 cubed. And at this point, I would just put all this in your calculator nonstop. So 4 times 3.14 times 343 divided by 3. Your calculator should be able to do all that as long as you put it in the right order. And you get 1436.03, which is closest to D. And I saw a lot of you getting D. So great job, guys. So it looks like for the most part, this is making sense. But as you can see, there's lots of little places to mess up, right? So just be careful. You don't want to get docked on points for putting in the radius. Now on this one, luckily, I think you would have figured that out because they don't have an answer that would match with the diameter. They were kind of nice on that, but a lot of times they will do that to you. All right, surface area of a cone. It says the diameter of the base of a right cone is 12 centimeters. So let's remember what a right cone looks like. So a right cone means that one of the, it doesn't look like an ice cream cone. It looks like that where the side of that cone comes down to the base and makes a right angle. The diameter is 12. If the total surface area of the cone is 306 pi centimeters squared, what is the length of the slant height? Okay, this one's kind of tricky. First, let's go back and remember the, good, I like how Derek's writing everything down. That's always a good start. Anybody remember the formula for the surface area of a cone? Okay, here's the formula, in case you forgot it. We're looking for a cone and the surface area. So pi r squared. Good. Good. Good, Mauda. Yes, you had it. You just, I know it takes forever to type that in, especially when you have to enter the spaces. Okay, so let's go back now that we have that. Yes, good, Derek. So our L is unknown, okay, which is our slant height. So if you remember, the L is slant height. Okay, good. So it looks good so far. So we have 3.14 times 6 squared, which is our radius, plus 3.14 times 6, good, times L, good. Now there's one piece of this we actually can fill in the left side, right? What does it tell us that we know about the surface area? Yeah, there you go, 306 pi. Now, what I'm going to do, Derek, I know you plugged in 3.14 for pi, which is what pi is equal to. However, I've been doing these longer than you guys have, right? So with some more practice, one thing to kind of look for is if they give you pi in like some of your information, sometimes that's a hint that you want to leave pi in there. Don't put in the 3.14 decimal. And here's why I put this one on here, because this is a tricky one. What I'm going to do, because we want to solve for L, what I'm going to do is factor out a pi. Do you guys remember how to factor? Ooh, we're busting out some algebra skills here, right? So look at the right side. Remember how if you look at both terms, if they have some factor that's the same, that you can pull that out, and then in parentheses next to it, you write what's left. Am I losing you guys that, or do you remember that? Yes, now that I'm reminding you, you're remembering it, right? Now, let's say that you forgot that. The way Derek's doing it would get you pretty darn close to this answer. It might be, you know, slightly off with rounding, but it should be real close. So the good news is, even if you forgot this and you were using the decimal approximation and you did your algebra right, you should be all right, Okay, so I don't want to put you in panic mode like, oh my gosh, now you don't remember how to do that. I'm scared to take this final. I'm just reminding you about this because it makes your life a little easier if you remember it. But that's why I love that Derek's on the whiteboard too, because he has a different way to do it, and that's always good to have more options, right? So what I'm going to do at this point is I'm going to, oh, actually, I can plug in my my radius. I forgot to do that. We know that that is 6, so let me do that. Oh, I could also, while we're in the mode of factoring, let me actually write those r's back in there. I could pull out an r also, because they both have an r, and then that would leave me with just one r at the beginning, which would be a 6. Okay, and then I can, right here, I can put a 6. So I have 6 pi right there. And so I could, man, I don't know, Elluminate is going crazy on me right now. I hope that you guys can hear me all right. But I can divide that 6 pi out on both sides. And I'm running out of room. I'm going to write what I have below, and then I'm going to put it up above. So the pi's on the left cancel, and the 6 pi's on the right cancel. So you're just left with 6 plus your slant height. And then on the left with the 306 and the 6, that actually divides nicely into 51. Okay, and then all I have left to do, let me transfer what I have over here. All I have left to do is subtract 6. Oops. So that would leave me with 45. That's supposed to be L for slant height. Okay, so if you got A already, nice job, very good. And if you didn't, do you guys see how to get there? Yes? Okay, good. Oh, let's see, Derek. So you pulled out your pi. That looks good. Yep. And then, no, yeah, this part looks okay. This part looks good. And then did you divide pi, or what happened from here to here with pi? So if you divided it out, and if you have 306 equals, yes, that looks good. Yeah, so keep working that out, Derek, and let me know if you end up with 45 or real close to 45, then that looks good. Okay, one other formula you want to take note of is the 3D distance formula. First semester we did talk about the 2D distance formula, which was just up to this point, and then 3D you just add one more dimension, the z's. So just remember that it's subtraction and then squaring. So just the x values, the y values, and the z values subtracted. And that finds the distance between any 2 points. So if you wanted the length of this line or the distance between those points, this is the formula you'd use. Okay, so the main thing on this one, how do you guys feel about this one for the most part? Do you think you could do this one if you have the formula? I think as long as you remember the formula, for the most part you guys are okay. Remember the tricky part is just being really careful with your signs, because you have that subtraction in there, so sometimes you end up with those double negatives. So just be really careful to double check your work. I think as long as you have the formula, plugging it in is pretty straightforward. Sorry, Derek, I was going to probably skip through this one. Sorry. That's why I was asking if everyone feels pretty good about it. Now, you guys do all have this PowerPoint, okay? So you can certainly practice this problem, and if you don't get one of those answers, then come to tutor time. Ask questions, okay? But I just want to make sure that we get through everything important. Okay, now we're getting into the Unit 5 stuff, so let's see. We might have some time. You guys should have this already from Unit 5. This is the flow chart. Because remember, we've all learned all kinds of tools about Unit 5, so this just helps you sort out when you use each tool. Don't forget that you're going to need law of sine and law of cosine. How are you feeling about, I think law of sine and law of cosine are one of the trickier parts of Unit 5. Would you like to go over one of these? I think I have a law of cosine problem. Would that be helpful? Type it in if you guys are like, yeah, law of cosine would be good because I really don't know what I'm doing. Okay, let's see. This one is not a law of cosine. Okay, all right, good. Well, maybe I'm not seeing a ton of you guys like, yes, let's do it. So maybe let's leave that for one of those tutor time things. So like I said again, you have this PowerPoint now. For the problems that we've skipped over, what I would suggest is to go through and practice them before the final. Because some of these questions are questions on your final. So that would be very wise of you to go through and double check on these that we are skipping over. I'm giving you the background information, but we just don't have time to fit everything in. So for this problem, just as a quick reminder, it's an isosceles right triangle. This side and this side are the same, which means these angles have to be 45 degrees each, right? And it wants to know what is the approximate value of the sine of one of the acute angles. This side also would have to be 3.5. So that means that you could use your special right triangle ratios. Good. If you remember that, that's real quick and easy, right? 1 square root of 2. If you know these are 1, these ratios here are 1, you just take that and multiply it by square root of 2. You could use your trig ratios. That is also an option. As you can see, that this is a lot faster, but it would get you there. Now, if you don't remember, yeah, and you guys also had that chart they gave you too that told you the sine of 45 is this ratio. Okay, and if you divide it now, this number here isn't going to match up with the ratio. There's something wrong here. It's not square root of 2 over square root of 2. It would be 1 over the square root of 2. But if you divide it out, it should match up with one of these decimals over here. Okay? So yeah, double check these from the chart. These would both actually be 1. The numerators on these would be 1. But you're on the right track. You're on the right track. So just make note of that kind of stuff and practice some. Yes, this one's correct. That would, but these would actually equal 1 if you have square root of 2 over square root of 2. So that's what I'm saying is the numerators here, it's 1 divided by square root of 2. Or square root of 2 over 2. It's probably the way it's written. That way we don't have a radical in the denominator. Okay. All right. So here you want the measure of angle R. This would be an inverse trig ratio, or you have to use sine inverse or cosine inverse or tan inverse. Do you guys feel pretty good about that type of problem? You guys just type it in. If we get to one where everyone's typing in like, yes, let's do this one, I don't get it, then we'll stop. You don't know that, Derek. All you know is that this is 90. Oh no, Derek left. Looks like we're having Illuminate issues. You guys are getting kicked out of here. Well, Derek did bring up a good point though. But all we know here is 90. It might look like a 30, 60, 90. We don't know for sure. So remember, we don't want to make assumptions. Okay, let's do this one then. So if we are looking for angle R, remember that flow chart? One of the first questions on the flow chart is it a right triangle? So we'd answer yes, this is a right triangle. We do see that right angle marking in there. And if you go down the flow chart, you'd find out that, okay, I can use the trig ratio, sine, cosine, or tangent. Okay? So we have to figure out which one to use. So yes, absolutely, that's the next thing you want to do is label the sides. So the hypotenuse is the one we always start with because it's across from the right angle, and that's the easiest one to start with. And then the side across from the angle that you're using is the opposite side. And then the last one left has to be the adjacent side, but it just means the one that's next to this angle here. This side is next to that angle. Now, if we're already missing the angle, we want to be sure to use two sides that we know. So in other words, we want to for sure use the 20 and the 21. We do not want to use the hypotenuse because we don't know anything about it. We don't know what the length of it is. So if we want to use the opposite and the adjacent, that tells us tangent. Tangent's the opposite over the adjacent. So tangent's the only one that uses those two sides in its ratio. So we say tangent of the angle. Sometimes it might be a number. In this case, we don't know the angle, so we use the letter to represent it, equals the opposite side. So notice the opposite side is in the numerator, so 21 over the adjacent side, which is the 20. Okay, now we want to get R by itself. R is what we are looking for, angle R. So in other words, we want to get this tangent away from the R. Okay, just like if this was, 3R, you'd say, okay, I got to get rid of that 3. What's the opposite of 3 times R? I would divide by 3. Well, the tangent's attached to the R here. What's the opposite of tangent, or how do we undo the tangent? How do we get it over to the other side, away from angle R? Okay, Zane, no problem. Thanks for coming. No, not divide. So tangent's different. All these trig ratios are different. Yeah, it's the inverse tangent. So remember, that's where the tan inverse, you might see that little -1 on your calculator. You want to do the tan inverse of both sides. Okay, so the tan inverse undoes the tangent. Now, you guys are, since you said divide, what I would like you to do is practice this on your calculator. Find your tan inverse button. And if you don't have that on your calculator, let me know, because I can send you a link to an online scientific calculator. So let's try it, guys, and if we get you can, Anthony, yes. So you can. It's not really multiplying by tan inverse. I know what you're saying, but yeah, we would say take the tan inverse. So you can divide 21, do 21 divided by 20, and then take the tan inverse of it. That's how you would say it. So we would say angle R over here on the left, because these two undo each other. And then we would do the tan inverse of, you could type it in 21 divided by 20, or like Anthony's saying, you can take 21 divided by 20 and change it to a decimal. Make sure you keep 4 decimal places. Now in this case, there's actually only 2. But if there were more decimals and it kept going, keep at least 4 decimals, okay? So we'd say angle R equals tan inverse of 1.05. So I'm getting 46.3972.